Hi, fam. In this tutorial, we are going to consider science paper 1, and that categorically is physics. We are going to have an exam reader lesson under a beneficial topic called waves. By the way, when we talk about a wave, there will always be a medium, and in that medium, there will be a disturbance that will be caused. So when we say a wave, scientifically, we are trying to say this is a disturbance caused in a medium. A very good example of a medium can be air, and in air, there can be noise that can be made. There could also be other sources that can disturb the flow of air in the atmosphere. Apart from that, we can have, that is water. A very good example can be a stream or a river. If I throw a stone into the river, the water is going to splash out, and as a result, that is more like causing a disturbance. There are also two types of waves. There is a longitudinal wave, whose very good example is a sound wave. There is also a transverse type of a wave, whose example is a water wave. And also we can be able to have another group of waves that are related to transverse waves. In this discussion, we are going to use that diagram and relate using these mini 3 questions that are placed on this diagram. The question says, the diagram below shows a representation of a wave. So this wave is starting from 0. So when a wave is starting from 0, and when it goes upwards, it gets to approach its turning point before changing the direction. Hence, the upper position of the wave is called a crest. And the same can happen when the wave is coming downwards. It will have its minimum turning point, where at least this is going to be called a trough. So this can be called a trough. On the upper, it can be called a crest. The distance between two successive crests is what is known as wavelength. Then from 0 going up to a certain maximum position, mind you, the wave is starting from here, and its highest maximum displacement is up to here. So this value is always the height of the wave, or the maximum displacement of the wave. So A, define the term wave. So I'm going to say a wave is a disturbance. A wave is a disturbance caused across a medium. A wave is a disturbance caused across a medium. Then B, on the diagram, clearly indicates wavelength. How are we going to show that these are the points under which or in between lies wavelength? Like I said, wavelength is the successive distance between two consecutive crests. If this is a crest, then this is also a crest. If this is the trough, this is also a trough. So the distance between this crest and that crest is the wavelength, but we are not calculating the value. Instead, we are trying to represent. Hence, we are going to draw a line. We put arrowheads and another arrowhead. And we're going to put the symbol of, that is a lambda, which we can be able to put like that. So having done that, it means we've represented the wavelength. C, if the wavelength of the waves is 4 meters and their frequency is 5 hertz, calculate the speed of waves. The first important thing to relate whenever you are asked a question in science paper 1, which is physics, is always coming up with the correct formula. So I'm going to say, when we talk about speed, we're talking about velocity. Hence, I'm going to say the speed is given by frequency multiplied by wavelength. On the right-hand side, you can come up with your data. Your data is an illustration which shows the values you're going to group, so that it simply shows you where you have a value and where you don't have a value. So I'm going to say the speed we don't have, the frequency we have, which is 5 hertz, then the wavelength is 4 meters. So we're going to substitute the information into the correct formula, where we're going to say this is equal to, for the frequency, we all know from the question, it's 5 hertz multiplied by, that is 4 meters. Then speed equals to 5 multiplied by 4 is going to give us, that is, a 20. But speed and velocity are given in SI units called meters per second. So meters per second, and then this is the answer. Whenever you're asked on how to calculate or how you're going to come up with an answer that involves a calculation, make it a habit and a priority to ensure that you come up with the correct formula. Afterwards, before substituting in values, ensure you collect your correct data. And having done that, you can now replace, but ensure to each and every value that you replace or substitute, attach units in order to represent the exact symbols. So 5 pairs multiplied by 4 meters, it's going to be 20 meters per second. And having done that means you should be confident from now on that you can really handle the question that can be brought under wave motion. Remember what I said in the previous minutes before even approaching the end. Ensure that you sit down and reflect and be able to pause where you haven't understood until you grasp the concept, and that you can be able to claim self-reliance. This has been your tutor, Mr. Sensor from Sensor Academy School of Tuitions. For now, till the next video, it's a very goodbye. Stay focused.